Hello everybody, welcome to my math vid. This is our honors topic, which hopefully you've had some experience with because you've been doing the study plans, but we're going over matrices. So, I don't know how long this is going to take, hopefully not very long, but it's going to be kind of hard for me to write with this pen, so it might be hard for me to write in these little boxes on this iPad, but be patient, please. Okay, so first of all, let's talk about what a matrix is. So a matrix is basically just we say it is a rectangular array of elements. So it is a rectangular array of elements. Okay, and it is arranged in rows and columns. So, for example, a matrix looks something like this. So, use brackets to represent the starting and the ending of a matrix, and it can have however many rows. So, example, this is one row, 6, -8, and 2. So these are all separate numbers. We're not doing 6 minus 8 plus 2. This is all 3 different entries. And then we have 7, 1, and maybe -4. Okay, I'm going to erase this out of this box over here. Okay, so this right here is our row. That's the first row. This is the second row. Okay, your columns go vertically. So this would be column 1, column 2, column 3. Okay, and each entry, so 6, -8, 2, 7, 1, -4, those are all what we call elements. Okay, so this is an element. This whole thing is a row. Going down is a column. Okay, so this matrix would be a 2-row by 3-column matrix. So we say it is a 2 by 3 matrix. Okay, and how do you name a matrix? So to name the matrix, you just describe its dimensions basically. So you say number of rows by, this X means by, number of columns. So rows always come first, so it does matter the order. Rows by columns. Rows by columns. R by C. Okay. All right. Let's scroll down a little bit. Equal matrices. So what are equal matrices? Equal matrices are matrices that have the same dimensions and their corresponding elements are equal. So they have the same dimensions. And corresponding elements, I really hope you can read this. Corresponding elements are equal. Okay, so for example, you may be given a matrix equation like this. You could say in this matrix here, 3x minus y and y equals 10 and -4. Wait, I want that to be x. Anyway, -4y plus 12. I'm actually going to change this to x over here. Okay, so these two matrices will be equal as long as the corresponding elements are equal. So this is a 2-row by 1-column matrix, so this element has to be equal to this one. This element has to be equal to this one. So we could say that 3x, that's an x, minus y has to equal 10, and x has to equal -4y plus 12. Okay, I'm not going to go through and solve this system of equations. We could just substitute in x into here and then solve for y. But this is what you'd have to do in order for these two matrices to be equal. Each element has to be equal. Okay, let's scroll down a little bit more. It says, can you solve for variables given an equal matrices? So yeah, basically what we just did, we would have to set up the systems. I guess we'll do that because we have a box for it. So again, I'm not going to rewrite it, but you have to substitute in your x. So in place of x, I'm going to write in negative 4y plus 12, because the last one was 3x minus y. Minus y equals 10. Distribute your 3 through, we get negative 12y plus 36 minus y equals 10. Negative 12y minus y is negative 13y. I can move that negative 36, or that 36 over by subtracting it. 10 minus 36 is negative 26. So then we divide by negative 13 and get y equals 2. And if we plug that back in, we had x equals negative 4y plus 12. So x equals negative 4 times 2 is negative 8. Negative 8 plus 12 is 4. So x would be 4, y would be 2. Okay, so you could solve for your unknown variables given an equal matrix like we just had. Okay, adding and subtracting matrices, kind of similar to solving like equal matrices. So to subtract matrices, I don't know why we're doing subtracting first, that's weird. Anyway, to subtract matrices, you can subtract two matrices if they have the same dimensions. So, for example, if we have, sometimes I'll just give matrices names like A and B. So if we say that, if we say like A equals, let's do a 2 by 2, negative 5, 7, 2, 0, and B equals another 2 by 2, 11, negative 2, 4, negative 6. Okay, so we have the two matrices. These are both 2 by 2 matrices because they have 2 rows and 2 columns. Okay, so we can subtract them because they have matching dimensions. Okay, 2 by 2, 2 by 2. So to subtract them, we just do A minus B. You're basically just subtracting the corresponding elements. So we're going to do negative 5 minus 11 for the top left. 7 minus negative 2 for the bottom left. 2 minus 4, and then 0 minus negative 6. Simplify that. Negative 5 minus 11 is negative 16. 7 minus negative 2 becomes a plus, so that's 9. 2 minus 4 is negative 2. 0 minus negative 6 is 6. Okay, so this would be A minus B. Negative 16, negative 2, 9, 6. And again, we don't do anything else with those numbers. We just leave them alone. Adding matrices, very similar. They have to have the same dimensions. So you can't add a 2 by 2 with a 2 by 3. If we do the same example, hopefully you still have it written down. I don't, but I have it written down on my paper. So A plus B, you're just adding the corresponding elements. So you would do negative 5 plus 11. You do 7 plus negative 2. And then you do 2 plus 4. And then 0 plus negative 6. Which, again, would simplify fairly simply 6 to 5, 6, and negative 6. Okay, so that would be adding matrices. So the most important thing to add and subtract matrices is they have to have the same dimensions, exact same. So they have to have the same number of rows and the same number of columns. Otherwise, you're going to have these extra spaces that you can't do anything with. Okay, moving on to the next page. All right, so now we get to the fun stuff, multiplying matrices. So if you look at this page here, it's all chock full of information. So multiplying matrices is a lot more complicated than just adding or subtracting matrices. So that's why we have this big old list of steps to do. There's really only like 3 steps though. So, however, step 3 has like 5 parts to it. So that's fine. Okay, so the first thing we need to do, step 1, is you need to make sure that you can multiply the matrices. So you can only multiply matrices if the number of columns in the first matrix is the same as the number of rows in the second matrix. So, for example, if we have these 2 matrices over here, the first matrix has 2 rows by 3 columns, so it's a 2 by 3. The second one down here is 3 rows by 3 columns, so this is a 3 by 3. Okay, so the first matrix number of columns, which is this one, has to match the number of rows in the second matrix, which is that one. So if you write it out like this, like I have, your inside dimensions need to match. Okay, so if your inside dimensions match, then you can multiply the matrices. So this one, first matrix has 3 columns, the second matrix has 3 rows, so we can multiply them. Hooray. All right. So step 2 is to figure out what the dimensions of your new matrix will be after you've done multiplying them. So the new matrix will have the same number of rows as the first and the same number of columns as the second matrix. So how I remember that is we have, again, I write this out, so I have 2 by 3 times a 3 by 3. So again, the first ones match. Oops. First ones match, so we are able to multiply them. The resulting matrix will be the outer numbers, so the 2 and the 3. So your resulting matrix should have 2 rows and 3 columns, so it should be a 2 by 3. And that's what we have. After that, you go ahead and draw your new matrix and label it out. Okay, and now comes the fun stuff. So now that we are able to know that yes, we can multiply them, and now we have our dimensions, check new dimensions, now we can go ahead and start multiplying things together. So let me scroll down here. Okay. Right. Okay. So step 3 is find the first element of your new matrix. I need to see my other ones. Okay. Wish I had these. Okay, I'm going to rewrite this down. Hold on 1 second. Just kidding. They're all written over here still. Okay, so to find each element of the new matrix will be the sum of several products. To find your first element, you will complete the following steps. You will multiply the first element in the first row of your the first element in the first row of your first matrix by the first element of the first row in your second matrix. This product will get added to the next 2 products. Okay, so you can go ahead and read these steps if you would like. I don't want to keep having to go scroll up and down, so I'm just going to try to show you what we do here. So you always multiply the rows by columns. So if you look at your first matrix, the first row is this right here, 1, 8, 0. So we're going to multiply the first row by the first column. Okay, so we multiply 1, 8, and 0 by 3, negative 4, and 7. So we have to multiply the corresponding elements together, so this one goes with this one, 8 goes with negative 4, and 0 goes with 7. So that's why we have here 1 times 3 gives you 3. 8 times negative 4 gives you negative 32. And then 0 times 7 gives you 0. Okay, after you have all those, we add them all together. So 3 plus negative 32 plus 0 gives us negative 29. Okay, so that goes in remember we used our first row. So we use a row 1 and column 1. So that's the element this goes in. So negative 29 goes in the first row, first column of your new matrix right here. So that's going to be negative 29. Okay, to get the first row, second column here, why is this not working? To get this element, we need to multiply the first row by the second column. Okay, so that's this next piece right here. So let me erase this. Now we're going to, we always do rows by columns. So now we do first row by second column. So we do 1 times 9, which gives you 9. 8 times 11, 88. 0 times negative 2, 0. So 9 plus 88 plus 0 gives you 97. And then 97 goes in the first row, second column. Okay, so I'm going to rewrite this down here. So we have negative 29. Then we have 97. And now to complete the first row, we have to do first row times third column. So right there. So first row times the third column. So I do 1 times negative 1. These two go together. So imagine if you're just like turning this matrix. So it just becomes, you're flipping it on its side. So 180 times by negative 1, 6, 12. That's how I picture it. Okay, so the 1 goes with the negative 1, so we multiply those and get negative 1. Eight times 6, your two middle numbers are 48. 0 times 12 is 0, so negative 1 plus 48 plus 0 gives you 47. And then that goes in the first row, third column. So our last number in the first row is 47. And then we're done because we're done with the first row anyway because we use the first row with all 3 columns. Okay, so then next, erase all this stuff. Next we need to get to the second row. So we're going to do the same process except now we're going to use the second row with each of these columns here. Okay, so the second row, first column. So we're going to multiply negative 6 with 3 to get negative 18. 2 with negative 4 to get negative 8. And then 5 and 7 to get 35. Then we add all of those together. And what would that be? 35 minus 26. 9. So 9 for that one. So your second row, first column, should be 9. No. No, that's right, yeah. Yeah, okay. 9. If I scroll down, I'm going to lose all this. So, hold on. Let me just rewrite it. Okay, one second. Okay, so now we're on the second row, second column. So I'm going to multiply 6 with 9, 2 with 11, and 5 with negative 2. So negative 6 times 9 is negative 54. 2 times 11 is 22. 5 times negative 2 is negative 10. Add all of those together, we get negative 64 plus 22 gives you, I can't do mental math, negative 42. Okay, so negative 42 goes in the second row, second column. So negative 42 here. And then last we need the second row and the third column. So we do negative 6 times negative 1, which is 6. 6 times 2 is 12. 5 times 12 is 60. Add all of those together, we get 72 plus 6, 78. And that's our second row, third column. Okay, so this is our resulting matrix. Okay, this is our product matrix right here. So all of that to get this matrix. Okay, so that's how we multiply matrices together. It's kind of a complicated process, but once you get the hang of it, it's not that bad. Alright, I know this is running super long, but we're almost done. Okay, so just to review, multiplying matrices. If you're going to multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second. Okay, and an example of multiplying matrices. Well, we just went through that big example. Let's do a smaller one. So let's say A is 2 and 3, and then B is negative 5, I don't need a comma, 7. Okay, so you're going to multiply the number of rows, or rows by columns. So we would go first row only has one element, so let's say we have 2. We need to figure out if we can multiply first. I forgot my first 2 steps. We have a 2 by 1 and then a 1 by 2. So the inner numbers match, and then our resulting will be a 2 by 2. Okay, so to get your first column, we do first row times first column. So 2 times -5, since there's only one element in each row. That's easy. This one right here is our first row, second column. So first row times second column here. So -2 times 7. To get this one is our second row, first column. So 3 times -5. And then this one, second row, second column. So 3 times 7. So we get -10, -15 down here, 14, and 21. Okay, and this one we didn't have to do any addition because there's only one row, or one number in the row and one number in the columns. So we didn't have to add anything together. Okay. So can you multiply A and B? We just did that, yes. What about C and D? So C is 3 rows by 2 columns. D is 1 row by 3 columns. So your outer numbers match, but that doesn't matter because your inner numbers don't. So no, we cannot multiply those ones together. Okay, and I'm going to skip this part because we're a little behind schedule here. Okay, naming a matrix. I'm going to let you just name the dimensions, see if you can match these together. I'm going to let you do that, and then we'll come back and go over it. So pause this in 3, 2, 1, pause. Okay, so hopefully your dimensions match here. You have a 1 by 2. Remember, you always go rows by columns, so 1 row by 2 columns. 2 by 2, 2 by 1, 3 by 2, 1 by 3, 3 by 3, 3 by 1, and 2 by 3. And then some special types of matrices. A row matrix is a matrix that only has one row. A column matrix is a matrix that has only one column. A square matrix has the same number of rows and columns. So if you look over here, this would be an example of a square matrix. So would this, 3 by 3 and 2 by 2. And then a zero matrix, a matrix that has only 0 elements. And what that means is, it doesn't mean it has no elements at all. There's not a number of elements. It means that it would look like this, 0, 0, 0, 0. That would be a zero matrix. Okay, and then the last thing I'm going to talk about in this video is scalar multiplication. So scalar multiplication is it's another form of matrix multiplication, but you're just multiplying a number to a matrix. You're not multiplying 2 matrices together. So each element of the matrix is multiplied by the same number or constant. And then a new matrix is created. Okay, so a scalar multiplication problem might look like this. It gives you a matrix x, and then it says find 5 times x. So to do that, 5x is just going to be 5 times your matrix. I'm not going to rewrite all those. But basically, you're just multiplying everything inside by 5. So you can just basically distribute all of this through. So 5x is going to equal, oh, there's 6 elements there, but it's 5 times 3, so 15. 5 times -2, which is -10. 5 times 6 is 30. 5 times 0 is 0. 5 times 8 is 40. And 5 times 1 is 5. Okay, and that is called scalar multiplication, where you're just multiplying by a number. You're not actually multiplying 2 matrices like A times B together. You're just multiplying a number, 5 times x, or anything like that. Okay, so that is all for now. Next time we'll finish these notes, hopefully, and talk about transformations with matrices. All right, sorry that I'm way over time. Thanks for watching to the end. If you did, please like and subscribe if you haven't already. I'm disappointed, but I believe in you. You can do this. Take the quiz. Adios.